Hi there. Thank you for watching this presentation and welcome. Today we're going to talk about parking meters, specifically getting a baseline assessment of parking meter activity in the city of San Diego. So the city of San Diego uses parking meters to encourage commerce by maximizing parking turnover and the utilization of limited parking spaces. Now, this activity requires enforcement, which requires staffing. And it's been noted that parking meter transactions seem to have decreased over time. And so there's an open question about whether or not more enforcement is required. Is it that parking activity has actually gone down, or is it that people are just being more delinquent over time? But the problem here is that transaction volume is variable. So we really need to understand the underlying trends before we can start to figure out if people are being more and more delinquent. So we are going to demonstrate a method to reliably forecast parking meter volume so that we can find the anomalous periods of high delinquency. And from there, we would be able to assess the need for more parking enforcement staffing to encourage compliance. So we started with a data set from the city of San Diego through their OpenData Portal. There were about 6 million daily listings of different parking meter poles throughout the city, averaging something like almost 15,000 daily transactions and roughly 20,000 per day in revenue. We also sourced daily weather data from the National Oceanic Atmospheric Administration, just on a hunch that weather might have something to do with parking meter activity. And so if we look here, this is transactions over time. This is the volume over time. We see here in the graph on the bottom, there was a huge shutdown in 2020 thanks to COVID and the coronavirus shutdowns. So all of our following analysis will start at January 31st, 2021 and going forward from there. But if you start there, you will still notice there is a regular shutdown of parking meter payments every January. There also appears to be a slight decline over time. The blue lines seem to be going slightly downwards over time. And we also can see that summer months tend to have more action than the winter months. The day of the week also influences parking activity. So Mondays tend to have the fewest parking meter transactions. Saturdays will cost the most per transaction. So there's differences in the days of the week as well. There's also a relationship between weather and parking meter activity. So these two charts, they are almost the same chart. So let's look at the one on the left. It shows transaction volume and its relationship with temperature, right? And the chart on the right is almost exactly the same, except we've removed Sundays and holidays. And so when we do that, we remove a lot of those zeros, and we see that there seems to be a relationship, a linear relationship between Sundays and between average temperature and parking meter transactions once we've removed those special days. Now, pulling it all together, so the black line here represents our weekly transactions, the sum of weekly transactions. And if we just look at the black line for a second, even though there's these little dips inside of it, we see a regular rise and fall in parking activity each year. You know, these big sort of sweeping trends. Now, if we also look at the purple dots, those represent holidays. So every week where there is a holiday, you see there's this little spike downwards, a little dip in parking meter volume, which is very predictable. And rain also seems to correspond with periods of low parking activity. So rain is the dotted blue line on the bottom there. And so you can see that when weekly rain tends to increase, parking meter activity tends to decrease. But it's an open question whether or not there's a direct relationship between those two, or if they both just happen to correlate with cold weather, let's say. And then, so we use multiple time series models to assess what's even the utility here of trying to forecast, or what's the feasibility of trying to forecast parking meter transactions over a 3-month, 90-day period. And so we use a few different time series models to address this. And we limited the training data from January 2021 to August of 2023. That's about 2.5 years, let's say. And then our 90-day forecasts from August to November of 2023 were validated or tested against the actual parking volume to see, hey, how close are we to the actual activity that's going on here. And so the first thing that we had to do was we took messy data like this. So these are the daily transactions over time. Look at all those bubbles. It's just kind of a big fuzzy mess. But we could see that there's a clear, thick line on the very top. We want to isolate that big trend on the top. And so we're using something called decomposition, seasonal decomposition, to isolate the trend. And we're removing what you might consider to be the noise or the seasonality, the weekly seasonalities, the annual seasonalities, to really get at what is the actual trend that's happening there. And once we've identified the trend, now we can start to build our forecast models. So the one that we like the most is the linear regression model. And it's based, and you can see here, the gray line, the gray squiggly line is actual data. The blue squiggly line is the forecasted data, the predicted values. And you can see they actually line up. The forecasted values line up really nicely with what's actually going on. There's an up and down motion associated with it, and it's also decreasing over this 90-day period. And linear regression model, we based this on the underlying trends of the data, the seasonality in the data, and also weather information. And we got 99.3% accuracy over that time when it comes to forecasting the actual volume of parking meter activities. We also looked at a series of what are called ARIMA models. And ARIMA models they predict future values based on the past values. Now you could see that we actually calculated only a 3% deviation, but this ARIMA model just feels different from the actual data, right? So again, we have this black line representing the actual data, then our multiple ARIMA models are there at the end there, and they just feel different from what's actually going on. And so even though we got a pretty good accuracy score, we're not at all convinced that this is a model that would accurately represent reality. But the linear regression model sure seemed to do a pretty good job. And so in conclusion, we did demonstrate the ability to accurately forecast parking meter volume over a 90-day period. And this will hopefully allow us to identify periods of deviation and delinquency which would require more enforcement staffing. So the next steps here would be to continue to monitor and update our models as new data comes in. So these models are mostly data driven, which means they can be automated pretty easily. Also, we would like to gather hourly data if it's available. What's the difference between 9 o'clock in the morning versus 2 o'clock in the afternoon? We currently don't have access to that data. We would also like to review parking meters by location. Maybe downtown is different from Berryessa or something like that. We would also like to review the number of parking violations and their trend over time. And along with that, we also kind of want to look at our current enforcement staff. Do we have more people than before, fewer people than before? Are they writing more tickets per staff, fewer tickets per staff? That kind of information, just to understand the delinquencies that are being found. And then finally, over the long term, we sure would like to assess the economic need for parking garages. So ultimately, parking meters are used to encourage commerce by maximizing parking turnover and the utilization of limited spaces. And there's trade-offs between construction costs, ongoing rent, impact to the city's revenue streams, and the drivability of streets. So we sure would like to incorporate that as part of a long-term analysis. But for the short term, we did demonstrate the ability to forecast parking meter activity and hopefully identify periods of delinquency that would require more staffing in the future, maybe temporary staffing, maybe daily staffing, something like that. So with that, thank you for watching this presentation. For more information, my name is Stephen Reagin. You can reach out to me at sreagin@sandiego.edu or check out the GitHub, sfreagin/parking meters. Thank you so much for watching.